All right, so now let's look at how to graph the function together. Graph 3 times half to the negative x power. Excuse me. All right, so there are going to be a few x value that we're going to try and to find the y value. I believe you're going to have some delta net problem of learning how to graph it, but on your delta net, it actually asks you to only plot 2 points and the asymptote. 2 points and the asymptote. So just by looking at it, your base is less than between 0 and 1. So I start with the decay, and your a value is greater than 0. So I don't have any x reflection. However, do you see that negative is in front of the x? So this one is actually going to have the y-axis reflection. So it's actually going to look like this. I'm just predicting what the shape is going to be like. So the pink shape is going to be what it looked like. So now let's go ahead and plot the points. Let's try a few. -2, -1, 0, 1, 2. Just because. Take -2 and plug it in. 3 times half raised to the negative second power. So what do I get? Boop, boop. 3 times half to the second power is 1/4. So I get 3/4. -1. Boop, boop. I get 3/2. 0. Any number to the 0 power is 1. So I just get 3. 1. What happened to the negative exponent? You flip it, right? So it becomes, half becomes 2 to the first power. So it'll just be 6. 2. Once again, negative exponent, flip it. -2 becomes +2. 2 squared is 4. 4 times 3 is 12. So now let's go ahead and then plot it. -2, 3/4, -1, 3/2, 0, 3, 1, 6, 2, whatever over there. So I connect them. Boop. And it should look like this. What will be my, and then notice it looks like how we predicted. What will be my asymptote? Guys, is there any shifting up and down happening to this function? No. So my asymptote will be over here, particularly horizontal asymptote at y is equal to 0. Horizontal asymptote at y is equal to 0. What will be my domain? X covers all of them, so -infinity to +infinity. What will be my range? It starts from 0 up. Do we have any y is equal to 0 value? No. So parentheses 0 to +infinity. Left-hand behavior, your delta math is going to ask some of that. So left-hand behavior is literally what is happening as you go to the left. All right. What is happening to your x value as I go to the left? Your x is going to go to, where is x going? -infinity. And your y is going to go to where? Where is your y getting? It's going to get closer, closer, closer to 0, right? It's going to get closer, closer to 0. So that's how you do the end behaviors. Right hand behavior, what's going to happen to x as I go to the right? X is going to go to +infinity. Where's your y going as I go to the right? Your y is going to go to +infinity as well. So that's how you do the end behaviors. All right, now let's look at this one. So you have y is equal to 2 to the x power shown below. On the same graph, sketch y raised to y equal to 2 to the x plus 4 power plus 3. Notice there's some sort of shifting happening. You all see it? All right, what kind of shifting is here? 4 left, 3 up. 4 left, 3 up. So I'm going to take each point, move it 4 left and 3 up. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So your graph is going to look like something like this. Now, how low should I go on the left side? Well, let's think about it. The original one had a horizontal asymptote at y is equal to 0. Would you guys agree that since I move it 3 up, new horizontal asymptote will be at y is equal to 3? Right? Because it used to be 0. I'm moving it 3 up. It's going to be at 3. So, yes, that's how you find the horizontal asymptote. In other words, horizontal asymptote will be found by, you start as y is equal to 0. If there's any up and down, that's how you move it. So just look at this one quickly. Horizontal asymptote is probably going to be y is equal to 3. I mean, it's pretty easy. That one, y is equal to negative 7. That one, y is equal to negative 6. That's how you find the horizontal asymptote. Okay? Yeah, that's how you do it. Since delta math is going to ask you to graph it, so how... let's just do this one together. How would you do this in a delta math is this. Y is equal to 3 is the horizontal asymptote. So you can draw your horizontal asymptote at y is equal to 3. Now, notice my base is 2, so it's greater than 1, so it's going to be exponential growth. But notice there's a negative in front of everything, so it's going to have a reflection over x-axis. So when I sketch it, I'm expecting something that looks like this. 1 in the gray. It's going to be below something. So it's going to be exponential decay. So keep that in mind as you're graphing. I'm just going to pick 2 points. Let's just do 1, okay? X is equal to 1. And then plug it in. Negative 2, 1 minus 1 plus third is equal to negative 2 to the 0 power plus 3 is... Alright, so you take 1 and plug it in. Any number to the 0 power is 1, so I get negative 1 plus 3 is 2. So y value is 2. That means 1 comma 2. 1 comma 2, not this one, 1 comma 2. And let's pick one more. I mean, doesn't really matter. Let's do 4. Why not? So x is equal to 4, plug it in, negative 2. 4 minus 1 plus 3 is equal to negative 2 to the third power plus 3 is negative 8 plus 3 is negative 5. So 4 comma negative 5. 4 comma negative 5. I know it looks like this, exponential decay, so just going to connect that like this. So on the delta math, just pick any 2 points. And with the horizontal asymptote, you should be good to go. For this one, what will be the left end behavior? Left end behavior, what happened to the x when I go to the left? X is going to go to the negative infinity. But where is y going? Y is going to get closer to 3. So y is going to get closer to 3 for the left end behavior. Right end behavior, x is going to go to the positive infinity as y goes where? Negative infinity. Domain, negative infinity to positive infinity. Range, negative infinity to 3 parentheses, because it's all below 3. Okay? Alright, so that is the end of the lesson. Go ahead and do the next few problems, and I'll see you in the class. Bye-bye.